Good evening to all of you. Myself as a coordinator of this program, along with Jitendra Pratap Singh, co-coordinator of this FDP, warmly welcome Mr. Arun Kumar, who is Senior Section Engineer, Northeast Frontier Railway. As in this FDP, our prime motto is to collaborate with the industry people. So Mr. Arun Kumar, who is the Senior Section Engineer in the Northeast Frontier Railway, he accepted our request to deliver a lecture. He did his BTech degree from MNIT Allahabad in 2014 in civil engineering, and this senior section engineer is in Indian railway system. They are in Group B, gazetted officer, and they are taking care of several things. They are doing permanent way, signal and transmission, mechanical engineering, electrical engineering, works and civil, and their responsibilities are supervision of sections. In this supervision of sections, they are manages or a section of railway assets. That railway assets may be track, signal, electrical lines, mechanical units, depending upon the department, through which department and which section they are deputed. And then again, they are taking care of the safety and reliability and timely maintenance. So another is technical leadership, safety responsibility, administrative role, then project work and modernization. So in this, Mr. Arun Kumar works in bridge investigation and repairing using various modern tools. And as his topic reflect that recent developments in inspection of bridges. So I'm requesting Mr. Arun Kumar sir to please continue. Arun sir, can you listen my voice? Arun sir, please unmute sir.
Okay, sir. Hello.
Yes, sir. You are audible, sir. Your screen is visible. You can continue, sir.
But my PPT is visible or
Yeah,
not?
Your PPT is visible. Make it full screen, sir. In slides.
Okay, sir. Okay, sir. Good morning to all of you. Hello. What is happening?
Sir, you are visible and your screen is also visible. No problem, sir. You can continue, sir.
Okay, sir. Good morning, all of you. My in our Northeast Frontier Railway, basically, my post is the Senior Section Engineer Bridge, Northeast Frontier Railway. We do inspection of bridges, repairing of bridges. Hello. Hello.
Yes, sir. Please continue, sir.
Nowadays, the technology increases and we are doing some technical advancement, just like inspection of bridges. For inspection of bridges, let's consider technically we do inspections, repairing and regarding, etc. Nowadays, we do inspections using survey inspection by survey methods, just like surface survey, lidar survey, thermal profiling survey, photogrammetry, terrestrial laser survey, and this is the surface survey. We do this survey on the surface and above the surface, and below the surface, subsurface surveys, and underwater foundation survey. This includes ground penetrating radar survey, that is GPR, ERT and SRT, and hydrophone and bathymetry survey. Next, uh, what is the workflow for this? Basically, ground ground survey with DGPS. First step. Second step, this is lidar infrared, TLS, and photogrammetric survey for above surface. And for soft surface, we do GPR, hydrophones, and ERT and SRT. Then after doing this, the data is collected and data processing done, and final report is generated. Some terms and definitions regarding the PPT. First is DGPS. DGPS means Differential Global Positioning System. Basically, global positioning system में what is the that there may be some error. What are the steps for DGPS? Receiving station located at a fixed known location receive position data from several GPS satellites, and then data obtained from GPS is compared to the known location of the station where we put the DGPS instrument. Any difference between these two is due to GPS error. This difference is applied to the individual GPS receiver and thus increased positional accuracy is obtained. The DGPS is more accurate than GPS. Second is LIDAR. LIDAR means light detection and ranging. Third, TLS, terrestrial laser scanning. Third, CRP, close range photogrammetry.
Arun sir,
हाँ हाँ okay.
can you go in PowerPoint presentation mode? Actually, the screen is very small, so it is not visible. And try to enter in full screen mode.
Okay. Full screen. This is
Yeah, I think it is near at the bottom, PowerPoint mode.
at the bottom. Participants.
I
Not
think
no.
fourth option.
Fourth option is new share. Participant chants reaction.
No.
Reaction.
In
Uh,
that
uh-huh.
PowerPoint only, screen projection is here. Click on it. I think it will be okay.
Oh,
Or just
where
maximize this slide. Maximize this slide.
slide maximize. Okay. Or show down. Notes.
Yeah, just click on this. Okay.
Okay.
Now I think it will be.
LIDAR survey. LIDAR survey is a method of capturing high precision 3D spatial data of the Earth's surface and objects using drones equipped with LIDAR sensors. This is a drone camera where LIDAR sensors are equipped, and the LIDAR system emits laser impulses and measures the time it takes for these pulses to return after hitting an object. Hello? By analyzing the return data, it generates detailed 3D point clouds representing the surveyed area. We can see from the figure there are four satellite GPS satellites, and here is a we can see lidar, and here is a station, GPS ground station. From here we can see the, yeah, drone runs drone runs, and it emits different signals, and that signals are going to the GPS satellites, and from there it goes to GPS ground station. And this, in this way, by analyzing the written data, it generates 3D point cloud representing the surveyed area. Now, after that, pre-processing is done. Defining area of interest. How we do the inspection? Basically, what is we go to the bridges and find the what do we want to inspect. Defining area of interest. After that, selection of equipment. What type of equipment that is be required, and after that, the drone we do planning for the drone planning, flight planning. What is flight planning? How much data is required? How we go for that. After that, data logging setup. For after that, environmental condition check. We check for the environmental condition. If it is good or not, we can do for that. Ground coordinates reference setup. After that, we finally go for the ground coordinate reference setup. After that, safety permissions are taken from police stations and army camp if any there. Then we do the test flight. Is I audible?
Yes, sir,
Hello.
you are audible, sir.
After that, we do the test checkup. After that, data is collected. Data collects after data collection, trajectory adjustment. We do the trajectory adjustment. Then
कैसे रन रहता है जी फोटिया के साथ?
Sir, please unmute yourself, sir. Arun, sir, please unmute. Yes, sir. Yes, sir, you are audible, please.
okay, sir.
Sir, you are audible, sir. Please continue,
Okay,
sir.
continue. After that, what we get from the leader data, we get the 3D model of the bridges and raw data. Sample images, as we can see the sample images from the leader. This is dense point cloud 3D points, and this is the texture model. Then we do for the CRP, close range photogrammetry survey. Drone photogrammetry is a method of collecting high resolution images of the earth surface or objects using drones equipped with specialized cameras. One bridges will contain a minimum of 1,000 images. We can see the images. Then what is the methodology adapted for the photogrammetric survey? First, we go for the data collection. How we collect the data? Flight planning. We do the flight planning. After flight planning, images are captured. Then, second step is image processing. Image processing contains image calibrations. After that, we get the output generation. Output may be we get output generations like ortho photos, topographic maps, 3D twin model. Photogrammetric survey. Flight planning contains drone flight planning for photogrammetric involves defining the objectives, selecting suitable equipment, and using planning software to create grid flight path with 70 to 90% forward overlap and 60 to 80% side overlap. Key steps include determining altitude for resolutions, incorporating ground control points for accuracy, and conducting pre-flight checks. After test flight, the main survey is executed and images are processed to generate outputs like orthomosaic RDMs, ensuring accurate and high quality results. Image processing, data collection, transfer of images to storage, verification of the images, organize and geo-image, sorting of images, ensure GPS metadata is accurate, pre-processing, metadata check, correcting issues, alignment and stitching, key point matching, type point creation, initial model, digital surface model, digital elevation model, image stitching.
Yes, sir.
Then output generation of DEM,
You are audible.
generation of DSM and DEM, then orthomorphic generation, then contour mapping, 3D model creation, then validation, then export and delivery. We can see the sample images of the closed-end photogrammetry (CRP), just like first A, B, C, D. In first image, we can see honeycombing surface of the pyre. The second pyre water filtration, we can see by red spots. In the third C, we can see the corrosions, arch ridge bend corrosion. We can see the corrosion. In the D part, we can see also the fracture of the arch ridge. Then we do for thermal profiling survey. This is thermal imagery is a visual representation of the heat energy emitted by the objects. Unlike traditional imagery that captures visible light, thermal imagery uses infrared cameras to detect temperature variations and translate them into images. These images use a color scale or gray scale to indicate different levels of heat, with warmer objects appearing brighter and cooler objects appearing darker, as we can see from the image. Then terrestrial laser survey. Terrestrial laser survey, it includes terrestrial laser scanning. It is a high precision surveying technique that uses laser technology to capture detailed 3D measurements of surfaces and objects from a ground-based perspective. It employs LIDAR. LIDAR means light detection and ranging sensors mounted on a tripod to emit laser pulses, which measures distances by calculating the time it takes for the light to reflect back from a target. These measurements create dense point clouds that can be processed into 3D model, maps, or other outputs. What are the features of the TLS? The first point is high accuracy. TLS delivers millimeter level accuracy, making it ideal for the applications requiring detailed measurements. Then second is rapid data collection. Captures millions of points per second, covering larger area efficiently. Versatility, suitable for diverse environments including urban settings, forests, and industrial sites. Then non-contact measurements, ideal for inaccessible and hazardous locations. Digital laser survey data of the bridge. Then conclusion, TLS in the bridge survey. This is high accuracy, captures precise measurement to detect structural deformations like cracks, bulges, and shrinkage with millimeter level accuracy. Detailed 3D model. Then it produces dense point clouds and highly detailed 3D representation for comprehensive visualization and interpretation. Then third point, early risk detection. Identify structural issue at an early stage, enabling proactive maintenance and reducing the risk of cost repairs and failures. Non-contact and safe. Facilitates safe data collection in hazardous and confined tunnel environments without direct physical contact. Efficient and reliable. Provides fast and consistent results, streamlining tunnel inspection and ensure robust infrastructure management. Advanced decision making supports better planning and execution of repair or reinforcement strategy through precise data driven insights. Sample images delivery. What we get from the first is 3D twin model generation, second is crack and corrosion detection. We can detect corrosion and cracks, and we can also generate 3D model. Then this is for subsurface, underground, or underwater survey of the piers or columns. What we do in this pre-survey planning, defining objective, equipment selection, and site assessment. Then sensor placement, positioning of hydrophones. Then we collect data from the hydrophones, active or passive listening, and continuous monitoring. Then data analysis, signal processing, frequency analysis, mapping results, interpretation and reporting. After that, we assessment of structural integrity, recommendations and report generation. What are the outputs of the hydrophones? Vibration profile of the structural element, acoustic signature for defect detection, noise profile from underwater elements, frequency analysis for structural anomalies, integrity index or health score of the submerged components. Air gun. Air guns are also employed as a power source for the collection of vertical seismic profile. An air gun is not a perfect source on its own. Combining a variety of air guns with various chamber size and shooting them all at once increases efficiency and makes it more reliable source. We can see the images of the air gun hydrophone and how it is reflecting back to the hydrophones. These are the results of the hydrophones, received level and frequency. Then bathymetric survey to measure and map the underwater topography of a body of water such as oceans, seas, lakes, rivers or reservoirs. Survey from many different types of research including flood indentation, contours of stream, reservoirs, leakage, scour and stabilization, biological and spill, and storage and fill in reservoirs and ponds, water quality studies and dam removal. Provides information about the depth of water and shape of underwater terrain. We can see from the images antenna we receive different signal and then we go for echo sounder. ERT oblique SRT survey methodology. ERT means electrical resistivity tomography and SRT seismic reflection tomography. Survey play a crucial role in evaluating subsurface conditions for a bridge project. These non-invasive geophysical techniques help identify potential risks such as weak soil, high groundwater level, fault lines, which could impact the bridge foundation and stability. ERT measures ground resistivity to map soil moisture, mineral content, and geotechnical properties, identify weak zones like loose sands or saturated layers. SRT uses seismic wave to detect deeper geological features such as bedrock depth and fault lines. Together, these methods create detailed 3D model of the subsurface, helping engineers making informed decision on foundation design and construction technique. Simple images of the ERT oblique SRT. What we get from the ERT and
Hello,
SRT, raw and process. Hello.
Arun sir.
Yes.
I think the slide is struck. Which slide you are presenting?
I am presenting slide sample images of ERT oblique SRT.
But I think, oh,
25,
25.
25 numbers. 25.
Okay. So it was 14 only in the window.
14 only. After that,
And now it
20.
has uploaded.
Okay.
Now it has uploaded.
Okay.
Change in this way.
Just change like this.
ऐसे ही change करना.
Okay. Now we are at the slide number 25. Sample images of the ERT oblique SRT. Deliver what we get from the ERT oblique SRT, raw and process data, comprehensive survey data, including resistivity and seismic wave information, 3D imaging model, detailed 3D visualization of the subsurface conditions, including soil layers and bedrock. Then technical report, summary of the survey methodology, key findings and subsurface interpretation. Risk assessment, identification of the potential risks such as soil instability and groundwater issues with the mitigation strategies. Then geotechnical recommendations we get. insight on suitable foundation design, construction techniques, and risk reduction measures. Then bathymetric survey that was missed in the 24 number slide. Bathymetric data collection using single beam or multi beam echo sounder along with the DGPS. Second step is carrying out patch test for multi-beam calibration every day. Pair to pair running of the cross-section line to identify navigable channel. Then continuous sounding at a continuous speed on the cross-section. Video and photography of the non-approachable areas. We get the cross-section and bed level chart from the bathymetric survey. Then it comes ground penetrating radar (GRP). GRP is a non-invasive geophysical method that uses electromagnetic waves to imagine subsurface. We can see the drone and GPR. GPR methodology. GPR operates by transmitting high-frequency radio waves into the ground. These waves reflect back when they encounter subsurface material with varying dielectric constants. Then second point, the reflections are recorded to create a profile of the subsurface. GPR methodology relies on the transmitting antennas, receiving antennas, and control system. It typically uses frequency ranging from 10 MHz to 2.6 GHz, depending on the depth and resolution requirements. Usually up to 5 to 7 meter depth. Then GPR survey equipment. GPR survey equipment it contains transmitter and receiver control system, antennas, shielded or unshielded depending on the environmental condition, data acquisition system for signal recording and processing, software for interpretation. GPR data structure. GPR data is recorded as radargram, which are 2D representation of the reflected signals. The data include the below information: time and depth. We can see by zooming the graph. GPR data processing. Noise filtering, removal of background noise and unwanted signals. Time zero correction, aligning the start of each radargram. Future extraction and gain adjustment, enhancing peak reflections, migrations, correcting signal distortion to improve spatial accuracy. GPR data analysis and interpretation. Identification of the subsurface features such as air voids, water table, stratigraphy, depth in estimation based on signal travel time and dielectric constant, visualization in 2D and 3D model. You can see in the images water depth, water table at depth 1.2 meter, air voids we can see by the circle voids, and visualization we can see the 2D or 3D model. Then report and mitigation. We can see the image how lidar and lidar survey take the images of the real image of the bridges, and we can see the web gap fatigue crack. We can see fatigue crack on the web web gap region, diagonal member of the cross frame, stiffener connection plate, top plane cross frame, bottom plane girder. Corrosion protection. How we uh, do the corrosion protections? Selection of metal or alloy, removal of corroding environment, protective coating, anodic protection, cathodic protection, corrosion inhibitors, innovative designing. Thank you. Hello.
Hello,
Hello.
hello, Arun sir.
Yes, yes.
Sir, we lost after 15, slide number 15. So can you explain from
Okay, okay.
15 to 20 slides?
27.
27.
Okay,
So
okay.
we lost the connection from slide number 15.
Slide didn't move.
Okay.
Slide didn't move.
From slide 15. Okay.
Yes.
These are the sample images of the CRP, close range photogrammetry. Don't that go very closely to the real structures. These are the images we can see. A, B, C, D, 3D twin model integration. First is 3D model we can see, and after that crack and corrosion detection. In image number D, we can see the arch reef fracture, and we can see the corrosion arch reef paint corrosion in the figure image C. Fire water infiltration we can see the image B, and in figure A we can see the fire honeycomb surface. This is done by CRP, close range photogrammetry. These are the positions we cannot in the figure A and B we can not go easily there. This require very large ladder, and this very helpful. CRP is very helpful here. These are photos that we cannot go there. We require power block for that. In figure C and D we require power block for there to go to inspect these positions. This is very helpful for the inspection of locations that are hazardous. We cannot go there. After that, thermal profiling survey. Thermal profiling survey. This thermal imagery is a visual representation of heat energy emitted by the object, just like it is based on the it is based on the is a visual representation of the heat energy emitted by the objects. Unlike traditional imagery that captures visual light, this thermal imagery uses infrared cameras to detect temperature variations and translate them into images. These images use a color scale or grayscale to indicate different levels of heat, with warmer objects appearing brighter and cooler objects appearing darker. Means uh, darker objects higher temperature, uh, cool temperature, and brighter objects higher temperature. Then terrestrial laser survey. Terrestrial laser scanning is a high precision surveying technique that uses laser technology to capture 3D detailed 3D measurements of surface and objects from a ground-based perspective. It employs a lidar. It requires a lidar sensor mounted on a tripod to emit laser pulses, which measures distances by calculating time it takes for light to reflect back from the target. Means lidar emits the laser pulses that go to the target, and from there it reflect back to the lidar. Then time calculation can be done, and after that we can calculate distances. After distances we can finally create a 3D model for the objects we want to for inspection. These measurements create dense point clouds that can be processed into 3D model maps or other outputs. The features of TLS: high accuracy. TLS delivers millimeter level accuracy, making it ideal for the applications requiring detailed measurements. Just like our we have a Saraigat bridge that is 400 feet, 122.2 meter, and it is very difficult for us to go for detailed measurements. It is 62-year old. We do TLS for that. For that, after we get measurements that we cannot calculate easily. Just we get camber of the bridge. Camber means deflection, upward deflection of the bridge. Camber of the bridge we get from this. We cannot easily calculate camber by auto level all total station, but from this we get camber. That is very important point for inspection of point of view. rapid data collection. It captures millions of points per second, covering large areas efficiently. Versatility suitable for diverse environments, including urban settings, forests, and industrial sites. Non-contact measurements ideal for inaccessible or hazardous locations. Just like in railway, hazardous locations means surfaces which are above the high tension wire. We cannot go there for inspection, and we require power block, which is not easily given for inspection point of view. If there is repairing, we are given, but if we want inspection, general inspection, then it is very difficult because there are many trains going up and down. It is very difficult. Then still is a survey. How we compare the conclusion? TLS in bridge survey, high accuracy, captures precise measurement to detect structural deformations, include cracks, bulges, shrinkages with millimeter level accuracy. Detailed 3D model produces dense point clouds and highly detailed 3D representations for comprehensive visualization and interpretation. Early risk detection identifies structural issues at an early stage, enabling proactive maintenance and reducing the risk of costly repairs or failures. Non-contact and safe facilitate safe data collection in hazardous or confined tunnel environments without direct physical context. Efficient and reliable, provides fast and consistent results, streamlining tunnel inspection and ensuring robust infrastructure management, advanced decision making, support better planning and execute of repair and reinforcement strategy through precise data given insights. What are the outputs of the survey? We get 3D twin model integration and cracks and corrosion. We also get cracks and corrosion from this inspection. Then comes underground survey. Underground survey, we do by hydrophones or acoustic survey. How we do? I think this slide I had explained. Hello, hello.
Yes, yes. No, 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 not this one. Till 25.
Okay, okay. Then hydrophone or acoustic survey. How it is done? Hydrophones defining objective. What is our objective? Equipment selection, site assessment. Then come positioning of the hydrophones. After that, active or passive listening. Then continuous monitoring. After that, data analysis, signal processing, frequency analysis, mapping results. Then interpretation and reporting, assessment of structural integrity, recommendations, and report generation. Then air guns are also employed as a power source for the collection of vertical seismic profiles. An air gun is not a perfect source of perfect source on its own. Combining a variety of air guns with various chamber sizes and shooting them all at once increases efficiency and makes it more reliable source. We can see the images how the air guns are re- transmitting signal, how the ultraphone streamer receives. These are the outputs of the hydrophones, air guns, hydrophones, receive level, frequency. Then bathymetric survey to measure and map the underground topography of a body of water such as ocean, seas, lakes, rivers, or reservoirs. Survey for many different types of research, including flood indentation, contours of streams and reservoirs, leakage, scour and stabilization, biological and spill, and storage and fill in reservoirs and ponds, water quality studies and dam removal, provides information about the depth of water and the shape of underwater terrain. We can also see the image how it is creating a cross section of the cross section of the channel or a river, and how it is creating a train, how it is generating a train of the underground water. Then ERT oblique SRT survey methodology. ERT means electrical resistivity tomography and SRT seismic reflection tomography. Survey ERT survey plays a crucial role in evaluating subsurface conditions for a bridge project. These non-invasive geophysical techniques help identify potential risks such as weak soil, high groundwater levels, and fault lines, which could impact the bridge foundation and stability. ERT measures ground resistivity to map soil moisture, mineral content, geotechnical properties, identifying weak zones like loose sand or saturated sand. SRT uses seismic wave to detect deeper geological features such as bedrock depth and fault lines. Together, these methods create detailed 3D model of the subsurface, helping engineers make informed decision on foundation design and construction techniques. These are the images of the ERT oblique SRT, raw and processed data, comprehensive survey data including resistivity and seismic wave information, then 3D imaging models, detailed 3D visualizations of the subsurface conditions including soil layers and bedrock. Then technical reports, summary of the survey methodology, key findings and subsurface interpretation, risk assessment, identification of the potential risks such as soil instability, groundwater issues with the mitigation strategy, geotechnical recommendations, insight on suitable foundation design, construction techniques, and risk
Okay,
reduction.
sir, I think this slide was visible from air. All the slides were visible. So, sir, hello.
Hello?
Ah, so basically you talk about 6 to 7 methods of surveying this bridge.
Yes, yes.
So, which techniques is more most economical one?
The most one is leader survey.
Which one is it? Can you go to that slide, LiDAR, where you are presenting
Last
LiDAR?
ERT oblique ERT SRT, subsurface. It was relatively more costly,
Okay.
but overall it was a complete project combining all six survey, and it is very difficult for us to evaluate which is more costly or which is not. These are all six. It was done in a single work. Hello, hello. Hello.
Yes, sir. Sir, one question is there. This ground penetrating radar, GPR,
Okay, sir.
this GPR, uh, showing range is 10 megahertz to 2.6 megahertz. Yes, sir.
Yes.
10 to 2.6 gigahertz.
Yes.
Its frequency range is from 10 megahertz to 2.6
2.6. Yeah.
gigahertz. So
Yes.
its depth depend upon the frequency. Is it so?
Yes, I think it requires more frequency means more energy. More energy requires means it requires for higher depth. Okay.
Yeah,
Uh,
its depth will go from 5 to 7 meter,
yes.
depending upon this frequency range. Am I right, sir?
Yes.
So one question that is coming in my mind, that is within the surface of the earth, some other factors are taking care, like it's what should be the dielectric constant of the layer to layer.
Yes. If there is just we think dielectric constant.
Or something, it is theoretical value that we are keeping always this thing as a constant parameter. Like once frequency is from 10 megahertz to 2.6 gigahertz, and we know that c is equal to frequency into wavelength. So
Yes.
depending upon that wavelength, if I calculate, its depth is not in from 5 to 7 meter, slightly varying, sir. So in my mind, it is coming that below the earth, my ground c is equal to f into lambda doesn't exist. Am I right, sir?
Yeah. Frequency c into lambda. C is equals to lambda into frequency.
Yeah, yeah, sir.
This frequency changes from medium to medium. Is it correct? Or
Medium to medium,
wavelength
yes, sir. Yes.
frequency changes from medium to medium, wavelength changes from medium to, but the speed remains same.
Okay, sir. Okay. It's next. What another question is from radiogram, radargram,
Radiogram.
radargram. You can come to that.
It's like
Yeah, GPR. That is,
GPR, ground penetrating survey.
yeah, GPR.
Yes.
Yeah, this GPR is they are using electromagnetic waves
Mm.
of 350 megahertz. Okay. So again, uh, below the earth, this this penetration takes which shape, sir? Is it axial or translational or which type? Like any penetration from the radar, if it is going within the earth, is it horizontal, vertical, or किस तरह से what should be its, that is coming in my mind, that I'm asking whether the question is relevant or not. I didn't know, but sir.
I don't know, sir.
Okay, sir. Okay, okay, okay. No problem. Next, these bridges are falling down. Nowadays, we are hearing. So, what should be the reason behind that, sir?
The bridges which are falling down, I think
Falling down
these
like
are
due to crack and corrosion.
no
If
steel bridges only.
our technologies is.
No. The reason behind this is only the we are going for PSC girders, pre-stitched concrete bridges.
Hmm,
If we do not go for the quality, we have to control
hmm.
quality control in the PSC is very important.
Okay, yes, sir.
Before in railway bridges now only ROB bridges and 18 point up to 18.3 meter are PSC girder. After that all the bridges above 18.3 meters are only steel bridges, except rail come road bridges, which are large long bridges, just like in the Bihar, Hajipur say PPT. PPTA, Patilput, 5 kilometer. There is rail come road base. It is still the whole load carrying capacity is transferred by still only the road above the road that is slab. But nowadays 18.3 meter girders and 12.2 meter girders, these girders are making PSC girders, and if they are made with poor quality control, they may fail.
Mhm. Yes, sir.
Failure of the girders in news in India, basically PSC girders. Any girders, steel girder is rare because ductile failure it shows symptom, but in PSC failure is somewhat brittle failure. That's the reason.
Okay, sir. So one again question is uh, this crack and corrosion detection. It
Yes,
is detected by whom, sir? By our radar technology or
CRP close range photogrammetry.
no any
These do
crack or corrosion detection
yes.
is detected by GPR technology.
The positions which are not easily accessible for us, just like uh, in open web girders, which in open web truss girders. In truss girders,
Yes, sir.
basically there are top cords
Yes,
which
sir.
are above the high tension wires. We cannot go directly that positions without block. We require power block,
Okay.
and power block is not easily given of the number of trains. There are number of trains running on the lines. Then this CRP is very good. We go for that. All the members which are above the ST wire, and the piers which are not easily accessible without ladder or pura inspection arrangement, then CRP is good.
So, one question for me, that we are using drones,
Yes,
and drone technology is not related to civil engineering. So, as a civil engineer, how can I understand what are the funds, what are various parameters we have to check in drone technology?
basically in drone technology we requires high CRP requires high resolution camera which can detect cracks, corrosions, loose bolts, and loose rivets. And we also require the at that type of drone which can go very closely to the ST wire, high tension wire. It can go means without disturbing ST wire. It can go very close to that. We see these, and after and for underground, basically we go. We don't have any team for this checking. What are the requirement for subsurface survey. But superstructure survey, we only go for camera, high quality camera, and good quality DGPS system, which can create 3D model. This is new
One
technique,
more
and this is
question
the
one
yes,
more question that just came in my mind, that if you are going to make this high speed trains, and they require very means special type of bridge, or a normal type of bridge will do the work if you are going for high speed trains.
high speed trains except bullet trains which are very frequent, means 5 minutes their gap is only 5 minutes, then it is very difficult for drone cameras also to inspect the bridges from top.
Oh, okay.
But except bullet trains we can go for drone cameras. If the speed is 120, 130, we go above for drone to take pictures and give data for inspection. or this is very good because
Now
we
the
do.
audience can ask their question. They can write in the comment section if you have any doubts.
Yes. Hello.
What are the this research scope in this in all this technology? What is the scope of research? How can we do some research in these technologies?
Research, basically there are two or three research going on, going in FR, in NFR from IIT Guwahati, just like painting. How, what what are the painting we can do? Basically, we do painting every 5 year by tenure, by inspection schedule. But there are techniques that are coming which gives their warranty that you cannot require painting up to 20 to 25 year. This time a Singapore company came and they came, they give quotations for painting of approximately 50 square meter, and they give warranty of 25 year for not we do not require painting. This type of research is going on, and one research is going on that IIT Guwahati is doing conducting research for painting over the bridges that reflects dust particle which accumulates over the surface, and after dust particle accumulation over the surface, algae or mosses developed on the surface, which creates a green surface on the steel bridges, which is not looking good aesthetic point of view, but they do not harm. Some of our senior says that algae is not harmful for steel bridges. It protects from sunlight. But IIT Guwahati is doing research that moss and algae should not grow on the surface of the steel. And third research is going on stress analysis of the bridges without doing inspection. We do inspection just like we take deflection of the bridge, but one bridge in our section that is on 250 feet long get distorted at the midpoint about approximately 76 outwards, and we do inspection after 15 days, every after every 15 days, which is very difficult. It is difficult because the site is 140 kilometer away from Guwahati, and we go and take inspection. But the research point is that without going there, stress analysis can be done by a computer. If we this research can be analyzed, stress analysis without going there, and only just like underground in Saraigarh bridge there is a computer setup that do silting scouring depth analysis of the piers. In this, just like this, we can do research for the bridges which are overstretched or which whose inspection is not easily possible. Hello.
Okay. Oops, let me check.
Sir, one question is there. Again, I'm asking one question that for any infrastructure assessment, we know that this ERT and SRT, ERT and SRT both can do the complete investigation of subsurface condition. Am I right, sir? As per your presentation also.
But
Even both,
SRT survey gives more depth result, means just like fault lines and fault lines are ये माने gives inspection more depth at more depth.
Okay, sir. So my question is, can we take it individually like ERT or SRT?
Yes, it can be taken individually.
It can be. Okay, sir. Sir, audience, please, other faculty member, please ask any question.
One question came from audience. That can we use these technologies in the this our infrastructure means normal building, residential buildings?
Yes, but normal buildings, what we get 3D model, it can be done.
So what will be the advantage and disadvantage?
Advantage means inaccessible positions. Inspection of inaccessible position is the inaccessible position. Inaccessible positions ka inspection is easily done by uh, drone survey leaders.
Okay. Audience, if you have any question regarding all these six technologies, you can ask from the sir, or else we can go for the conclusion. Arun sir, can you give the phone number, your phone number and email ID
Yes, yes, I will give
in the chat box?
in the chat box. Okay.
For the audience, if you have any doubt, you can call to Mr. Arun Kumar. He might be working at that
Evening,
time, but
sir.
he
Am I
can
audible?
help you. Okay.
Good evening, sir. Am I audible?
Doctor, yes, sir.
Yes,
Yes, sir, you are audible.
Sir. Sir, good evening. Sir, my question is,
yes.
the question has been actually asked that why so many bridges are collapsing or falling down, even not after the corrosion or longer use, but during the part of construction. The project is not even complete and it is collapsing and crores of rupees it is getting just wasted. So can we use the drone technology for that purpose? Because it looks like heavy loss.
Yes, it can be. Then drones leader is very good because it it can it is computerized. It thinks is computerized. The any shortcoming, any deficiency in the part of the bridge is noticed, and it is showing. But the
Suppose
one bridge,
I could
one bridge, I
I
think.
could find the disturbing figures. There are somewhere 17 bridges they collapsed, and this is happening in Bihar only. The rain is, same quantity of rainfall is in the adjacent areas also, and the construction is also continuous. But exceptionally, I could find it here, and that is a very disturbing figure.
The
So it is just stuck to
quality
my
control,
mind
the
if this
quality control
technology can be used.
technology is there, but quality control is by manual. The concrete part is quality control of concrete part is manual. If we go for RMC, ready mix concrete, then how we can 100% sure that the grade of concrete in the design section that was 53 or 43, it is used or not 55. These are the poor quality control, nothing else.
Okay.
Thank you for this session, Arun sir. Arun sir. And special thanks for this session, and the presentation was nice and very quite informative. All the six methods that were used for investigation of the bridge technology, they are very useful and they are quite interesting. And with this, if you audience, if you have any question, you can ask, or we can conclude this session. Okay. So we can conclude this session, and the next session will be starting at sharp 7:30. Meanwhile, you can complete the feedback.
Thank you,
Okay.
Arun sir. Thank you,
Thank you,
Arun
Arun
sir.
sir. Thank you, Arun sir.
Thank you, thank you, thank you,
Thank you,
thank you,
sir.
sir.
Thank you.
Can I close my